In this video, we're going to take a look at Ohm's law and have a just extend our discussion of the relationship between voltage, current, and resistance. So basically, Ohm's law, it just points out the mathematical relationship between these three items here. So let's take a look at this circle down here, and notice that you have a V, which it's used for voltage. That's shaded in, and then on the bottom we have I and R, current and resistance. So the mathematical relationship for this particular circle here, let's say the highlighted part is what we want to find. So that would be voltage. That would be equal to the current. Since they're both on the bottom, you're multiplying current times resistance here. Right. Then for this relationship here, notice that the places of voltage, current, and resistance don't change. It's just what we're looking for changes. So in this case, I is shaded or current is shaded. So if I want to find current, then I would take the voltage, which is on top here, and divide it by the resistance, which is down here on the bottom. Okay. And then finally, let's see, resistance is shaded in. So mathematically, I can calculate resistance by taking the value of the voltage and divide it by, the value of the current. All right. So that's it. That's pretty much it as far as the Ohm's law. So let's make this a little bit more concrete and apply it to the circuits that we've built so far. All of our circuits have had the value of the voltage have been 5 volts coming out of our Arduino board, and we've used the same 220 ohm resistor in each of our circuits. So we know voltage and we know resistance, but what if we want to calculate the current that's running through that circuit? Well, to calculate current, we need to take voltage, in this case 5, and divide it by resistance, which is 220. And if you do that on your calculator, you're going to get 0.0227, and we will round that off to 0.23. Let me actually bring this down here a little bit. So we'll round to 0.023, and this will be in this is basically 23 thousandths of an amp, or in this case it would be 23 milliamps. This is what you would see. And to put that in perspective for you, 10 milliamps is enough to produce like a pretty good zap. You'll feel 10 milliamps. So 23 milliamps you're definitely going to feel that. Okay. So now you see why it's definitely important that we remove the power as we're changing components in and out, because if we don't follow safety precautions in, make sure we remove power, this is what could be going through your body is 23 milliamps, and like I said, you would definitely feel that. But that's Ohm's law. So from this point forward, like any circuit that we build, you'll be able to calculate any of these values, provided that you know at least 2 of them. Okay? 2 of the other ones.